Hey everybody, this is extra tutorial 3. In this video, I will be discussing about dicts and the concept of aliasing. So let's recall dicts. A dict is a mutable data structure which is made up of key and value pairs. A dict is basically a mapping from a unique key to the value. This concept is also known as hashing, where you have a unique key which points to a value. The important thing to remember about keys is that it has to be immutable. You cannot use a mutable object as a key in a dict. You can think about why this makes sense. A key which you can alter later loses its purpose altogether. So as discussed in the last extra tutorial, the immutable types we know about are strings and tuples. So other than the primitive data types, that is ints, floats, etc., strings and tuples can be used as keys in a dict. However, the values in a dict can be mutable. You can even use a dict or a list as a value inside a dict. So let's consider some examples. In this particular dict, we have integers as keys and strings as values. Now consider another example. Fifth grade of a school has two sections, each having some students with a roll number beginning from 1. We just can't have the roll number as a key to store the names of students, as this will lead to same keys and duplication. So we can use a combination of roll number and class section as a key in the form of a tuple. Here you can see how roll number 12 in different sections is handled. Consider another dict. Here we have a list of strings as values. Numbers of words in each element of the list is the key here. We can store a student's data in the dict using a dict as the value. Here, the key is a student's enrollment number and the value is a dict containing some essential information about the student. To fetch a value at a particular key, we just do d and in square brackets we mention the key. This returns the value at key E123, which is a dict. If we want the age of a student whose enrollment number is E235, we can just say D E235 and age. Now let's discuss some commonly used dict methods. For this, consider this particular dictionary. A.keys returns a list of the keys. A.values returns a list of the dict values. A.items returns a list with two tuple elements which are key value pairs from the dictionary. We can also remove key value pairs from a dictionary. A.pop with 1 will remove the specified key from the dict. A.pop item removes some key value pair from the dict if the dict is non-empty. You can see the altered dictionary. Now let's consider the concept of aliasing, in which many of you are facing issues. According to Wikipedia, aliasing describes a situation in which a data location in memory can be accessed through different symbolic names in the program. Thus, modifying the data through one name implicitly modifies the values associated with all alias names, which may not be expected by the programmer. As the definition talks about modification, we can be sure that aliasing concept carries importance for mutable objects. The mutable objects that we have studied are lists and dicts. We can have two types of copies of a particular object, shallow and deep copy. We will see this through examples. Say we have a list a equals to 1, 2, 3, 4, 5. There is a function id that we will call on a. ID of an object in Python is an integer which is guaranteed to be unique and constant for this object during its lifetime. You can think of this as some particular memory location for better understanding. Now let's say I am making a copy of A. We can check B. I want to now append 6 to B. So let's check now the values of A and B. B is as we wanted it to be. Now let's check A. Oh, the value of A also changed. This is not what we intended to do. Let's check what is the ID of this object B that we have created. As you can see that ID of B is same as ID of A. This means both A and B are pointing to the same memory location. So if I modify any one of these, the same effect we will see for the other. This is known as deep copying. B is a deep copy of A where both refer to the same memory location. Now we will make a copy in some other way using slicing. Say C equals to A colon, which means we want the complete list A in C. C looks the same as A. Now let's append 7 to C. C is as we wanted it to be. Let's check A. A did not get modified. This is exactly what we wanted. Let's see what's the ID of C. The ID of C is different to that of A. So it makes sense A and C are referring to different memory locations. This is known as shallow copying. C is a shallow copy of A. Let's see another way of checking the type of copy. We have this list A. We will make a deep copy. And now let's make a shallow copy. If we have a deep copy, A equals to B returns true, as well as A is B returns true. But if we have a shallow copy, A equals C returns true, but A is C returns false. This is what the concept of aliasing is all about. You have to be very careful about this. As we have seen for lists, in the same way you can yourself try for dicts. For dicts, we have a built-in method copy for creating a shallow copy. So that's it for this tutorial. Hope you liked it. And now you are clear about aliasing. In the next tutorial, I will discuss the different ways of importing modules, and I will also talk about indentation in Python and how to save yourself from these errors. You can write to us for any doubts or feedback. Thanks for watching.